A very good afternoon. My name is Aater Suleman, and I will be talking about Docker. It's this wave that has taken over our industry in the last few months, and I can safely say it's the fastest growing technology I have seen in my career. The adoption rate is just immense. In a little over a year, it has actually captured not only the attention of just the developers and the innovators, if you will. It's also captured the attention of really large companies. At this point, I am personally aware of 170 out of the Fortune 500s that are actually looking at using Docker in their technology. Typically, Fortune 500s, by the time they get to it, takes years, and this technology is less than 2 years old. So that sort of gives you an idea of how quickly it's caught on. There are deployments. The Docker team is so busy they cannot actually handle the sales effort that is actually needed to support what's happening with them and how many calls they are getting. So it's definitely a very fast-growing technology, and today what we're going to try to do is unravel some of what makes Docker so special. Why is it taking over the world at the rate that at which it is? So I'll do some basic concepts, talk about some high-level stuff, then we'll go a little deep into some commands, some of the details, and then end the talk with going over some practical examples of how I myself and my team, we have actually deployed Docker for many of our customers and the results that we have seen. So I'll go over about 2 or 3 case studies in detail on what it could be and what it could be used for, and I'll give you, that might give you ideas on how you could take the knowledge and apply it back into your organization. And then we'll end up with a small hands-on lab. We'll see if we can, my teammate here, Jay, is furiously trying to see if he can make it happen so that we can actually have a hands-on experience for everybody. The audience is slightly more than we had anticipated, so if not, we might have to just do it as a demo. And for those of you who have a Windows laptop, we'll have to figure out how to get on Linux on your own. Our plan was to just have just cloud computing instances for everybody, and you all could just SSH in and start working with us and follow along. So we'll see what happens. Jay, you still have an hour and a half. Make it happen. Okay. So yeah, I already talked about what my goal for today is to basically give you a basic understanding of what Docker is, why it is so hot. Second, give you an understanding of how to work with Docker, and that'll be through some slides and then through a hands-on demo or a workshop at the end. And then lastly, and I think most importantly, give some ideas on how other people are using Docker today, so you can take that knowledge and apply it to your organization. So myself, Aater Suleman, a co-founder of Flux7. And the second bullet here is a mistake. My secretary put it there. I told her to take it off. I teach. I don't want my affiliation to be known on this campus. I do want to add that, and don't tell anybody in Austin that I said this, but I think your campus is better than our campus for sure. So at Flux7, what we do is we provide people with consulting services around cloud computing and DevOps. What that means is we actually help people take advantage of the cloud better and leverage new technologies like Docker in building better workflows around the IT infrastructure. And that applies to both dev as well as ops. We are honored to be one of the Docker partners. There's only 7 global foundation partners of Docker, and we are one of them. We have had some clients all over the country of different sizes. I'm joined here today with my colleague, Jay Patel, also same affiliation, unfortunately, and we are working together at Flux7. So why learn Docker? I mentioned this already. I think it's the fastest growing IT technology I've seen in my career, and by a margin. So for example, Hadoop's adoption rate, we all know about Hadoop today, and it's definitely it penetrated the market very well. Hadoop, if you actually look at the penetration curve for Hadoop, it's like about an order of magnitude slower than Docker. So that's the magnitude. As soon as these guys really started making a noise about Docker a year ago, We had about 50,000 downloads in less than 30 days. Over 100, I know that number is actually over 170 at this point, for Fortune 500s that are actually trying out Docker and trying to figure out what to do with it. And it's impacting the code pipeline, if you will, at many different levels, starting from how we code, how we test the code, and how we deliver the code. And because of all this, Docker is attracting a lot of attention from the investors. So they raised $15 million last year, just less than a year ago. And then last week, they raised another $40 million. So they're growing at an exponential rate. So what we want to talk about today is some basic concepts around Docker and some terminology, Docker commands, some must-know features. We'll go through a hands-on tutorial, and then talk about some real-world solutions that are operating in the wild today that we have worked on. So one question, I just want to know my audience a little better. How many of you have actually toyed with Docker already? Are there any people who are already using Docker in a project? Just a couple. And how many of you are here because you have a use in mind, or is it just more for general purpose knowledge? So you have a use in mind, raise your hand. Okay, excellent. The other question would be, are there any, just to get an idea of what kind of organizations are you affiliated with? How many of you are with startups? And then how many of you are with the other extreme, multi-billion-dollar organizations? Okay, so we have a pretty even mix here. From a role standpoint, operations, how many people here are managing IT operations? Very few. I see all the hands that are like kind of saying so that's like 50% or something to me. And then I assume then the most of the crowd is developers. Are there any managers here, like project managers or? Okay, great. So mostly a crowd of developers. So we'll definitely focus more on that aspect of Docker. And so let's first talk about some basic terminology. So what is it that makes Docker so attractive? So 10 years ago, when the virtual machine technology really started catching on in the wild, roughly 10 years ago. So Intel added VT to the x86 instruction set. And there was a lot of VMware and a lot of companies sort of jumped on board. We were actually seeing a lot of traction from that, and we've come a long way since using the virtual machine technology. If you really go back and revisit the same question, why was it such a big deal when virtual machines came around? So the thing was, virtual machines were allowing us to have isolated environments using the same hardware. You could run an application and make the application feel like it's running by itself. You got different failure domains, so if one virtual machine went down with one application, the other one did not go down with it. So it was basically the isolation aspect of it. Applications got the illusion that they were running in their own operating system, in their own hardware, on their own set of hardwares. And underneath, the hardware was really shared. There's one, so if I was to draw a layer diagram, it was basically the shared hardware with multiple operating systems running on the same hardware. In many cases, those operating systems were actually the same, because the only real reason to run multiple operating systems was because every virtual machine required its own operating system. Systems have overhead, very high overhead, because there is background threads running, there is processes. There's a lot of overhead around virtualization. I started my career as a chip architect. So from that standpoint, I know that underlying work that was happening around chip architecture and processors and multi-core processors, there was a lot of discussion on how would you actually, because every operating system inside a virtual machine is managing its own resources, which makes it particularly difficult to fairly share the resources on the hardware, or efficiently share the resources, because it's like you just have to slice the hardware, and then each operating system is the only one that has the master knowledge of what's actually running. Still, it really made a very big difference. But there was a lot of overhead with it. So from that idea, if you look at it from that lens, what Docker really does is it actually provides a very lightweight way of providing isolation. If the goal was isolation and the goal was not to run two different operating systems, Docker does a really good job at it because it does not require, it can give that application the illusion that it's running by itself without actually requiring the running of an extra operating system. So for the same system where you would run 5 or 6 copies of the operating system and just choke the system, you could be just running one operating system and have tens of applications running, each one of them thinking that it's running by itself. So that's the concept really there is the Linux containers that got added into the kernel around 2009. And they were usable, they've been usable for half a decade, but what really makes Docker special is that they made those containers, that concept of doing lightweight isolation, extremely accessible so that we could just download Docker and you can just start playing with it. It does not take, the steep learning curve is gone, and there's some other aspects about how the file system was written that make containers a bit hard, less accessible than the way Docker works today. So lightweight is a very big part of it, which makes it, and opens up avenues for brand new ways of doing things. For example, Google's moving away from virtual machines into using containers for this, because virtual machines had overhead and they were just using them for isolation. If isolation is the goal, you could actually use containers instead of virtual machines, for example. Portable. So Docker containers do tend to be portable as well because they're typically smaller files. They do not need all the operating system in its entirety. We've all worked with virtual machines and they're really nice because they are portable. But one of the biggest problems with virtual machines is that it's hard to port them because they're large files that are very difficult to take from one place to the other. And try to synchronize two virtual machines. I have a virtual machine and another colleague of mine has a virtual machine. I make a change. How do I get that change over to my colleague? If I send them a new virtual machine, it's a 20 gigabyte file that I may have to transfer over. So what Docker does is, it's one of the most interesting aspects of it. It actually makes it extremely portable. It really turns that environment, that isolated environment that we talked about, into very much like a version controlled environment. So it can really take a diff. If you have a container and I have a container and I make a change to it, I can really just do a Docker diff at the end and see what have I changed in my container. Just like a git diff, they actually follow the same semantics as diff. And then I can do a Docker commit, which will be a local commit to my Docker repository. And then I can do a Docker push, and I can push it to a global repository. And the push is going to look precisely the size of the delta rather than the entire container being pushed. So if I'm making just change in one configuration file in my Docker container, getting it over to you is transferring less than a kilobyte of data, or whatever the size of that one file is. So they operate at the file granularity. They don't actually, unlike Git, where the merges are at the line granularity, Docker works at the file granularity, but it's still extremely efficient because you can install a piece of software and send everyone in your team email or a request to say, can you guys do Docker pull? And they would just pull the Docker container and just get the deltas. The entire environment, now everyone again has the same environment that they started out with. Extremely important consequences for those typical problems that we've all run into where works on my laptop does not work on your laptop kind of problems, because everyone has a very similar environment. They all are working off of the same baseline. And then cross-cloud infrastructure is another one of those, because Docker containers run on top of Linux, and the underlying machine that is hosting the Docker containers, often referred to as a Docker host, they can be a virtual machine or a physical hardware. It does not care. So I could be running Docker containers inside Amazon Web Services, and I do that all the time. We could be running Docker containers straight on my laptop. We could be running Docker containers inside a different provider. They actually isolate you from the underlying environment, which means you can just write the application, get it working, and just port the container over with all of its prerequisites. It does not have dependencies on the underlying system. So it's that detachment, the portability, and the lightweightness that makes it so interesting. So what are the kind of problems that we all have seen? So inefficient code pipeline management, doing manual QA, pushing code. Actually, I was just talking to somebody yesterday, a very large company out of Austin, and they said that the amount of time that they have to send code back from QA to developers is about 20%. So every time a code release candidate comes in, about 20% of the time on the QA team is just wasted because something used to work on a developer laptop but does not work in QA, and they have to send it back to the developer, and then the developer has to figure out how to reproduce that bug on their laptop so they can actually fix it. That's a pretty high overhead to maintain. So the inefficient code pipeline, there's inconsistency across environments. We've all been there. Between dev and QA and production, there's always deltas that exist. And each one of those points, I like to call them just divergence points, each one of those diverges cost, literally in terms of technical debt, when your environments don't match. And resource provisioning takes a long time. You're either moving lots of stuff, like an entire virtual machine, or if you're using just a code, then you have to compile it on the other side and take care of any dependencies. So if you push code from laptop to production, it could take a long time. And then you're running, oftentimes running your virtual machine, say in Amazon Web Services or Rackspace, inefficiently as well. So, which leads to increased bills. So all of these actually are touched, but there's not one tool that is just a be all and end all, and there's no magic here. But Docker can actually provide a solution to each one of them, and I will go over some of those examples with you guys. So Docker, as they state, it's a build once, configure once, and run anywhere environment. And by the way, one thing I did not make clear up front, please feel free to interrupt me in the middle. I'd much rather that this be an interactive discussion. So what are the interesting components and elements? So Docker would consist of a Docker client. That's just a client software that you can have running, say, on your laptop, where you can give and issue Docker commands. The Docker client in the backend connects with a Docker daemon. The Docker daemon typically would run on a Linux machine, which has Docker installed on it and has the kernel 3.9 or newer, which is almost everything today, Ubuntu 13.10 and beyond, the new versions of CentOS. Amazon Linux supports it out of the box at this point. So, so that would be your Docker host that's running the Docker daemon. In addition to that, there's another component, which is basically a Docker index. A Docker index is really a Git repository of Docker containers, if you will. It's just a repository where you can push containers and pull containers from, just like you would do with a Git repository. And there are a couple of ways of doing this, which is you could set up your own private repository, which there's open source code out there. Or just like GitHub, there's a thing called DockerHub, where you can go make an account. And the pricing is also very similar to GitHub. You can just use that to push and pull your containers. Going forward, if your compliance requirements allow it, I would definitely recommend at least starting out with DockerHub, because the private repository lacks some very critical features. So the commercial version of it is a lot more user-friendly, and they give you some free repositories to start toying with it. So that's where I would encourage you to start. Docker containers, they are the actual containers where the applications are running. So a container really consists of a file system. So it has its own /root. All the files on the container are isolated from other containers as well as from the underlying host. So it's like, for those of you who have done chroot in the past, it's very much like doing a chroot jail to a certain part of the file system. Then other things that make it more interesting than chroot is the process space is also isolated inside a container. So if I log into a container and I run top, I only see the processes that I started within that container and not the entire operating system. So the PID space is, PID namespace is actually separated. In addition to that, there is the actual ports. The container actually gets its own set of ports. So each container has its 65,536 ports of its own. So it does not have to, an application running inside the container could just be talking to port 80, could just open up port 80 just like you would on a machine. And another application in another container could also open port 80. They may be on the same host. And Docker allows you to just map them to different ports and actually forward the ports outside. Another important concept is Docker images. They're really the equivalent of virtual machine images. So this is the entity that you carry around. If you want to send somebody a Docker container, you would send them a Docker image. And it contains the file system, the information of really the snapshot of the file system. That's what the container is. But what's interesting about these images versus virtual machine is that they are actually they could be version controlled because they are layered. And the file system works such that you have a set of changes and then you do a Docker commit and then you make another set of changes and they go in a different layer and so on and so forth. So as a result of that, the containers can actually, the images can actually be pushed to a version control system. You can diff and see what have you changed since the last time you did a commit. Just like git diff, there is a Docker diff. So you can type Docker diff and see what files have been changed since the last time you started this container. Extremely beneficial when you're trying to debug one of those ugly bugs where it works on my laptop, does not work on your laptop. Have you changed something in the environment? It helps you catch those really nicely with being able to actually see a list of files that were touched during a particular session. And then layers also allow us to do that fancy thing about being able to port containers easily. There's another important concept called a Docker file. So a Docker file is, think of it very much like a chef puppet recipe. Any one of you guys write chef puppet or Ansible recipes, by the way? So a few of you. Or a bash script that would actually bootstrap a machine and get it to the point where you want it to be at the time of boot. So a Docker file is really one of those things. It's a plain text file. You pass it on, and you can build a Docker container which can be created using a Docker file. And we'll look at an example of a Docker file. It's just very simple. One of the things I really like about Docker files is the simplicity. It does not require you to learn a new language or a new DSL or anything. It's really run this bash command. If you want to add a file, you just say add and name of the file. The file gets added into the Docker container from the outside where you're running the command. And just extremely simple syntax. Takes about 15 minutes to learn the entire syntax really, because it's just bash and just simple copies and as you're used to dealing with bash already. So that takes us to, so once we have the basic concepts down, quick recap again, we talked about layers, images, containers. We talked about the Docker repository. Takes us to some interesting commands that you can do with Docker. So installing Docker, it used to be a much bigger pain up till a year ago because most of the distributions were not supporting it out of the box. So there would be like a change that you would have to make. For example, in Ubuntu 12.04, you had to go in, add like a repos list, and then update the kernel. Not the case anymore. And again, just within 1 year, all major distributions are now supporting Docker, and you could just type the equivalent of this in any other distribution. I'm generally using either Ubuntu or Amazon Linux these days on AWS, and it's just a matter of just writing rpm install Docker, and it just the latest version gets downloaded. Some basic commands, some of them for those of you who use Git, it would be rather obvious what this means. So Docker pull is really just Git pull. You get a container from a repository. Again, this is kind of interesting. Even when you're doing it for the first time, it's valuable because, again, remember the layered file system. So let's say you have one container that is for application A, but it builds on Ubuntu 14.04. And now you're about to download another container, which is for application B, but also builds on Ubuntu 14.04. You would actually not have to download the base Ubuntu anymore. So the only thing that'll download is like 5 megabytes, 10 megabytes, and you can get an entire application down with its own isolated space, which will look like a virtual machine. Docker logs, it shows you the log of a running job inside a container. We'll talk about what I mean by a running job. You could run multiple jobs inside a container, but there is some syntax and some best practices around how many jobs you really want to run inside a container, so we'll get back to that. Docker commit, exact same semantics as a git commit, so just a local commit for a container. So you have a running container, you can just do a git commit, or Docker commit in this case. It'll take a snapshot of the container, which is equivalent to creating a layer, and push that layer into a local repository. Docker images, you can just run this command and obtain a list of all images. Docker diff, this command is the one that I think really what's made Docker what it is today, because it's the ability to diff two file systems efficiently that allows you to push a file system to a version control system. I mean, in theory, we could take an entire 5 gigabyte worth of file system and push it into a Git repository as well. There's nothing really stopping us from doing that. But it's the efficiency at which Docker is able to do it using the layered file systems and keeping track of as the files change that makes Docker what gives Docker the power that really is able to reflect. Docker build, this is basically when you want to build a Docker image from Docker files. So there's Docker inspect. If you have a running container or an image, you can actually inspect it to get a lot more detail about the entity. There's a thing called Docker attach. So Docker containers are very much like virtual machines in that you can actually attach and you can open up a bash terminal, a bash shell inside a Docker container and be working on it. You can install SSH inside a Docker container and really work with it like you would work with a virtual machine. And then there's Docker kill, which will just kill the main process of the container. So this is kind of operative when you will be working with Docker containers. Every Docker container starts with exactly one main process. That process is what determines the lifetime of the container. So you start a process. When you create a Docker run command, and we'll be going through that, you have to specify a command that the Docker container is going to start with. And it's exactly one command, one process that needs to start. And when that process finishes, the container goes away. So that's the lifetime of a container, from the start of that main command to the end of that main command, which is why when you Docker kill that one command, the container goes away. This is kind of fundamental to the entire concept. So then there's two schools of thought from there on. Some people argue that Docker is meant to run exactly one command inside a container, and that's the way it should be used. So if you have a LAMP stack, your Apache, your MySQL, should run in two separate containers, or your application tier, if you have the PHP, should run in separate containers, and you should never violate that rule. I actually subscribe to the second school of thought, which is that when you are using Docker, initially, you need that smoother transition from today, where we are used to being able to log into our servers or our virtual machines. So I typically do recommend running at least an SSH daemon inside your Docker container, so you can later SSH into the container just for debugging purposes. Once your container is stable and you know that it's just going to work, and by work it means A, it's going to work, B, you are getting all the logs out. Why do we log into servers? I guess that's the underlying question. We log into servers typically to get logs, typically to reproduce a bug that we can't reproduce elsewhere. So for the same reason, if it's a Docker container that you cannot get into, in my experience, I've had a lot of grief around that. Part of it is also that my work with Docker started very early on when Docker was 0.3. So there were even times when the Docker itself was buggy, and you would really need a method to introspect and see what's happening inside the container. I still think it's valuable to sometimes run more than one processes. It just makes life easy. And really that's a debate in the community, the Docker community. Some people subscribe to what I'm saying, and then there's the other school of thought where it's one process per container and no more. How would you run multiple processes inside a Docker container? If you wanted to, and there are times you have to, say you want to run SSH and Apache, that's where some of our Python tools come in really handy. So supervisor is typically what the recommended best practice. So you could actually set up a supervisor conf file inside your Docker container, put it in your image, and then your Docker run command could look something like Docker run, name of the image, and then supervisor -n. Supervisor -n runs supervisor D in the foreground mode, the supervisor in the foreground mode, and starts all the processes that you wanted to start. Remember, the lifetime of your container is equivalent to as long as your supervisor process continues to run. When that finishes, the container is going to go away. Other not so pretty tricks you can play there are like putting sleep commands in shell scripts, and I've done those as well, like writing infinite loops that keep the Docker container alive. But really, if you want to do one process, just stick it right as the main command. That's the best way to do it. The other thing is that the main command is, remember we looked at Docker logs earlier? The main command is, it's std out goes straight onto the Docker log. So you can actually see it's std out. So yet another reason to do it the right way. And we can just do Docker run and just do a supervisor -n. So there's some important Docker features to know about. There's the DockerFile. We briefly talked about it. Let's peel the next layer of the onion. So we have these Docker containers, all these things, and you want to build a Docker container. You may want to build a Docker container for running Apache Web Services with, say, PHP, PHP FPM, and you want it all set up with fast CGI. There's several steps that it takes. You can automate them all using a bash script. We've all done that. You can automate them using Chef, automate that process using Puppet, Ansible, tool of your liking. Yet another thing that gets added with Docker is that you can use a Dockerfile. I have actually done all of the above. I've used Docker containers where I use bash to bootstrap them. I've used Ansible to bootstrap them, Chef to bootstrap them. And they were done at different points in time where Docker files were not stable enough, so I started out with doing some bash. Meanwhile, Chef, there was a project that was using Chef, so I had to do some Chef plus Docker as well. Ansible is one of my favorite tools, so I eventually started using Ansible. Docker files have become really stable over the course of my experience with Docker, and I do think they're one of the cleanest ways of doing it. Extremely simple learning curve. So if you want to see what a Docker file looks like, it's just like run cd xyz semicolon, run this command, do whatever bash command you actually want the container to run, basically. So that's one, but there's the other advantage, which is actually the more deeper and more interesting advantage, which is where it actually beats doing a bash script as well as Ansible and Chef and Puppet at this point with Docker containers. The Docker files are actually themselves run in a layered fashion. So remember we talked about layering and having file system layers. When you specify the sequence of steps to bootstrap your container in a Docker file, after every step, a new snapshot and a new layer is created. And then you run the next command and a new layer is created. And then you run the next command and a new layer is created. So you may run like one Docker file with 30 commands in there, and you'll have 30 layers created. It's the same image, but it'll have 30 layers inside of it. Why is this so important? Because we all make mistakes. Your first Docker file may not be the correct Docker file. You will realize it later that, oh, I missed that one important dependency that my code was needing. In that case, Dockerfile, since it's taking all those layers, and let's say we have a 30-line Docker file, and you found a bug in line 29 of the Docker file. In a traditional bash script to bootstrap, if I found a bug in line 29, when I make that change and do a fix and then run it again, all 28 will run again. And we have all sat through those painful apt-get cycles of things just updating while you were just sitting there, hoping that line 29 was fixed the correct way. Docker, since it, after every step, was taking a new layer, it's actually smart enough to know that for every layer, what commands went into creating it. So it can actually skip the first 28 commands automatically, and you'll actually see messages printing like just taking from the cache, and only run just the 29th line that you just changed. Extremely fast for debugging DevOps. For those of you who raised your hand saying that you've done Chef and Puppet and DevOps in general, the biggest pain with DevOps is the time it takes to test your changes. It's like 90% waiting and 10% work. So Docker files make a really big difference there by skipping all those things that already worked and taking you straight to the problem. And the general syntax is, there's the instruction. This is the Docker specific format. And then there is the actual argument that needs to be run. So an example of an instruction is run, and then the argument. There's a few Dockerfile commands that are interesting. So for just maintenance purposes, you can put a maintainer name at the top. It just gets ignored during execution. Run is the one that you'll most likely use, so it will basically look like run. You could put any bash command here, ls, create a file, touch a file, as needed. There's add. So these are times when you're creating a brand new Docker image and you want to add a file from your machine you're on and put it inside a Docker container. You can specify a source path and a destination path. And this could be a file or an entire folder at this point. So it could just but this is a copy, this is not a mount, just keep in mind. It's actually going to make a copy inside the Docker container. There's the cmd command. This is basically, you can actually provide the default command for Docker to run. There is a command called expose. Really, I think this command should be and will be deprecated over time. So I would not encourage you to use it because as the community has evolved, it's kind of becoming a unanimous opinion that it's a bad practice to do an expose. But in a Docker file, currently have the ability to expose a particular port on your image, which is exactly why this command is kind of funky, because there is no such thing as a port on an image. Port should be tied to a container, not an image. So this was kind of a non-purist way of doing it. They put the expose command in there. Really, the way you want to do this is have your image built without any notion of ports in it, because images and ports don't make sense together. And when you run your actual container, based off of that image, you specify what ports you want actually exposed. There's a thing called an entry point. This is basically very similar to the CMD. The major difference is the time at which it actually runs. One runs at the time the container starts. The other one runs as a part of the Docker file itself. It just specifies the entry point of where you want to start executing commands in your Docker file. So in my experience, generally, while they are actually both widely used, the CMD and entry point, kind of for the same reason that the port is kind of, it's a bit icky when you say the image has a port. This is basically making the image and giving it a default command to run when the image starts. Sometimes it's a great idea. If you're creating a container and sending it to a colleague whom you don't want to make them go through the hassle of learning the command to run it or the main command, you can just say, just Docker run this particular image and it will work. Where do I find that useful? Sometimes front-end developers, if you have HTML, CSS guys on your team, they want to test their HTML, CSS on their laptop, do not really want to know how you run your Ruby on Rails thin server inside. You can just make your thin server command just be a part of the Docker file, or same thing for your manage.py commands in Django. You would not just make them a part of your entry point. Other things you can do inside a Docker file, it's running those steps, so you can actually specify if there's any environment variables. You can specify the working directory of the path where to run those commands, the user ID. So this is like a run as equivalent of that. So this is like running as this particular user ID. And then there is a command called volume. This is taking a volume on your host, and this is the way this differs is, remember I talked about the add, takes a file from the source and put it in destination. Volume, take a folder on the host and just mount it inside the Docker container. So it's not a copy, this is actually a mount. Later on I'll go into a little bit more detail on some of the pitfalls around this. Another important concept, DockerHub, very similar to GitHub. You can create a repository, you can add, you get like 5 free repos, I believe. After that, you can pay $20 to get 10 repos. You can create user accounts. You can actually have other people in your company create accounts and then add them as collaborators. It does save your images, saves your checksums, and you can have public repositories just like GitHub and private repositories. And public repositories are very interesting in themselves because you can actually help somebody else out or use a public repository sometimes. So you can just do, there is actually a very famous repository for WordPress, for example. If all you want to do is set up a WordPress, I only remember his GitHub username, unfortunately, not his actual name, dbfink. So dbfink is the GitHub user who has posted a repository pre-built for WordPress on DockerHub. So all you have to do is docker pull dbfink/WordPress, and you get a system that already has MySQL, LAMP stack installed, ready to go. The password, the master password for the WordPress just prints on the screen when that container runs. And you can just go in and start working with WordPress in 5 minutes. And you can have it running on your laptop and then push it to production later. So other things that are actually happening here in the public repository I think is very, very exciting. One of them is Docker themselves are creating more and more public repositories that are vetted by Docker. So they just 3 days ago announced about 10 new public repositories that include, I believe Django is one of them if I recall correctly, Flask is another one. So basically code bases and code stacks is what they're calling it. They're calling them code stack repositories, I believe. So you can just download a Django repository and just, that'll give you the bare bones Django install and then just put your code inside of it. Sometimes you don't even need to go log into that container because you can really take your volume where your code is and mount it inside your container. It's a Django stack and it just comes up and just runs. So you get like just this black box where you can just plug in your code, hit fire, and your website begins to show up. Very powerful concept actually, because this allows you to test your code without having to think about all the dependencies and everything up front. Other things that I think one of the most interesting applications of public repository that I have come across, there is a company, Austin-based, called AppSoma. And there is anyone of you here heard of AppSoma? So they're doing some really cool work. So there's a problem in biotechnology and bioinformatics that some scientists would like run simulations, generate some results, publish a paper, and then just not be there anymore. PhD student graduates, or they're not accessible, or they change their computer. And 2 years later, if somebody looks at those results, there's no way to validate if they were actually done correctly or not. This problem, as I mentioned, I'm a chip architect, so I started computer architecture is where I started my career. And we do the exact same thing in computer architecture. We run simulations with processors. We build our own chip architecture simulators and tweak them, and they're our own entity. And then when the PhD student graduates, you just do R minus RF, and boom, now you have 10 papers that people could or could not believe. It's up to their discretion. Or spend a lot of money to validate if what you said is correct. So bioinformatics is much higher stakes than computer architecture. So there was, I think there was a famous example that Ken, the CEO of the company, gives where something like $300 million were wasted at a research lab because they thought that a paper was actually correct, and they spent years trying to validate the results, and it turned out that there was a bug in software that had led to the results that it looked like. So it was huge, massive losses. So what AppSoma is wanting to do is every time you publish, and so then the community graduated to the next level where the student does not RM minus R at the repository, and boom, like here you go, you can, and I'm graduating. The problem with that is don't ever know how to run that code or how to run that code in the same environment that the so what I'm trying to do is that the student has to upload, the researcher has to upload a public repository, self-contained environment to validate. They can go in and download the container and run it and plug the same input and see the same output, and then they can investigate if there's a bug in there or not. So a lot of the time that's wasted in just reproducing other people's work goes out of the door. With very little documentation or complete documentation required. And I think there's going to be more and more use cases of this. Software delivery, just in general, could be towards these public repositories. I've already seen say the process, let's say you want to get a shell inside a Docker container. The way you do that is you say your main process is going to be the bash shell. So you say /bin/bash is my command, and If you just do /bin/bash, your container is going to start and just die immediately because bash is not meant to run in background mode. So for bash, you have to specify -i, which gives you an interactive shell, and you can interact with your container like you're SSH'd into a server. Install the software that you want to install, and then at the end, take a snapshot using Docker commit. That's one way of building a Docker container. The other way of building is the DockerFile I mentioned. So that's the interactive mode. There's also a daemon mode where this is like, say you want to run Apache inside a Docker container, you just run it in the daemon mode, so it goes in the background and does not print anything on the screen. There's also a foreground mode where when you run a Docker container, the std out of the main process is printed right there in your shell where the container is actually running. Docker diff, we talked about that. It basically gives you a diff of what files have changed since the last commit. We have Docker commit, which is the actual commit equivalent to the GitHub commit. You can have Docker create. This is where you use a Docker file. And Docker file, there's a few things that you can actually do with it. One of them is, so I talked about how easy it is to do. There is the add commands. There's a few places where Dockerfile does fall short as well. Every step, remember, is you run a Dockerfile step, and then it takes a layer. To take a layer, the machines actually turn off. So you have you have a container that starts. Your Dockerfile has a command called run. You run, and then after the run, it stops the machine, takes another image, and then starts the next command. What is that? Where does it become a problem? It becomes a problem because if you set an environment variable in the previous command, the machine was stopped and restarted for the next step. The environment variable does not carry from the previous step to the next step. So, for example, some variable that you may want to set, for example, environment is equal to production, which all of us do sometimes. If you have 3 commands that need that variable, you cannot just say export env is equal to production and then just run the 3 commands inside the Docker file. For each one of those commands, you will have to say environment is equal to production, environment is equal to production, and environment is equal to production, because information that is not written to the disk is not carried from one step to the next. So important thing to note, and that's where it gets a bit ugly as well. So one of the things that annoys me the most sometimes is when I have to do like an if statement or a for loop in bash. It's just extremely ugly. You have to put it all on a single line for a Docker file to work. So you'll say run, and the entire for loop has to be packed into a single line and just put right there. Sometimes I have found it to be, if you have a complex code structure that needs to run as a single step, first of all, try to break your steps. The advantage of breaking the steps is that you will be able to use that cache very heavily and very effectively. But if there is code structures like an if-else statement, if there's a bash if-else statement that you want to run, it does not make sense to run it as 2 steps. And if it's a single step, you can make it really ugly and put it in a single line. Just make it crammy and put it in a single line. What I sometimes do is, if it's a complex structure, I just put it in a separate text file, and I do like a sequence of add that text file inside the Docker container, and then run that text file using bash as a shell script. So achieves the same purpose, but keeps your Docker file a little clean and a bit more manageable. But there is a trade-off there. Now you have 2 files instead of 1. So yeah, there are times when you have more than 1 entry points. Mentioned that if you want to have 2 processes run, then you could use supervisor. That's the most typical way of doing it. DockerHub, you can just create new repos, very much like GitHub. You can push a container to DockerHub. Then for volumes, that's just the concept which we mentioned earlier. Volumes are basically where you take a folder on the host and you can mount it inside a Docker container. Extremely valuable for building a Docker container that, say you're building a Docker container for doing QA and test. You don't want to fix the Docker container to have a particular version of your code. That's going to be the entire of what you want to do. So the way you want to do it is build your Docker container with everything that is needed to run the test except for the code that needs to be tested. But you'll still have the paths hard-coded to that particular folder. And your actual latest code can be downloaded by your Docker host and mounted inside the Docker container at that location every time. And I'll go through a very detailed example of doing this later. There's also port forwarding, so you can expose ports to the host They can be auto-mapped, or you can define a specific port on the host. For example, a very typical thing to do with SSH is that you would want to take a Docker containers SSH port, which is 22, and forward it to port 2022 or 2222, 4 twos to the host. Example of what a Docker file looks like. So we talked about this. This Docker file is just to set up an SSH service in a container. It's actually a standard file that was uploaded by a Docker employee. I just got it off of DockerHub. And here's what the Docker file looks like. You would have, say, a run command, and after that, a bash command, which is just very much like a bash command. Another run command here, run commands expose, which as I was discussing, is kind of being discouraged at the moment. And then you have the command. Remember that when you put the command, the CMD instruction in a Docker file, this makes whatever is in front of it the main process for the container. You can still override it on the command line, but this is what becomes the main process. So what does this do? This implies that if I had just put SSHD here and did not put the -D, SSHD returns very quickly. SSHD, if you just run it by itself, is a daemon. It goes in the background right away. And Docker, as soon as it sees that the main process has quit, it's not in the foreground anymore, the container gets killed. So it's a very common pitfall when you start out with Docker the first time. Keep in mind that whatever you put as the CMD or as the main command on the command line has to run. That is what's going to determine the lifetime of your container. If that command returns, all your other processes in the container will be killed immediately. So this is why there's the SSH -D, which basically puts SSHD in a foreground mode rather than a background mode. And supervisor, the flag is -N, which puts it in the foreground mode rather than the background mode. So a few things we talked about, and I'll just go into some real-world examples of where Docker has come in handy. So there's simplifying just configuration of systems. There's improvement of developer productivity, multi-tenancy, talk about that in a second. Consolidation of servers, so you can take different servers, in this case really different tiers of an application or different applications, and put them inside a single virtual machine or a single physical device. Kind of very similar to the effect that virtual machines had on hardware. Docker can be used to do that on top of virtual machines or cloud infrastructures as well. There is the application isolation. This is kind of handy for distributing software. The example I mentioned with biotech, where you could just send people a container rather than sending them the code, so you don't have to, the container does not have to, the code when we set it always has to accompany that README file. And how many times do we all get emails about our README files and why something did not happen the way it was suggested in the README file? So this takes care of that. You send them a container and they can just run it. Code pipeline management, look at an example of that in a second. Extremely good debugging capabilities that come with the caching, as well as the ability to see any environment changes through the diff command. And then some rapid deployments because you're only passing delta around your different environments. So let's dive into some examples. So case study one first that I want to talk about is one of our clients, Horan and Bird. This project was actually started mid last year, and they're a solar panel manufacturer. The problem is kind of interesting to understand. So the business problem was you have, so something I was very new to the solar panel industry, and the way they explained it to me was, well, you have a low customer engagement. You don't realize it unless you're a solar panel seller, I guess. That when you sell a solar panel to somebody, they put it on the top of their house. They really forget that it exists over time. Like it becomes just a part of the property and people just move on. They don't realize that you as the solar panel manufacturer did add something to their lives. They don't, for example, what do we do with other services? Like these are annoying emails that we all get every month from all the software vendors that we have bought any software from. The solar panel guys don't have the opportunity to do that, to send tips and all that stuff. The worst part about this is also that people tend to put solar panels on the top of their house and also forget that it's there. And they assume that it's always going to work, and then one of these days it stops working. Every house is configured with a solar panel such that if the solar panel goes out, the electricity starts coming in from the city, and you only realize that it's out at the end of the month. So you really have a problem here, a business problem here, where your customers only call you when they're really upset at you. And the last problem that they had was very low collection rates. They were leasing out. So again, I'm not a business guy, but very interesting facts, like if you think about it, utilities like electricity bills, for example, have extremely high collection rates, like barely anyone defaults on them. And the reason is that it's one of those cases where they have the ability to cut power if you don't pay your bill. Same is not the case for a lot of other industries. So the solar panel guys had it that way as well. You put a solar panel on somebody's house, now they own it, they stop sending you the lease payments, what are you to do? So those were their business problems, very high level. The solution that they suggested, I thought it was very clever by their marketing department, was the source of the solution. That rather than just deploying solar panels, we will also do like an Internet of Things application. And they would actually put, with solar panels, they would just put monitors out there in the field. It's not a groundbreaking idea from the United States market. Does anyone of you have solar panels at home, by the way? So it's still relatively common in the US. People have been doing monitoring software here for a few years now, but in Australia there was none. So they had these customers, they would just put like a measure power output of the solar panels, store the data, and create some reports, and then send these reports out to their customers in an email. So you get like a monthly energy report or something. And that gives them an opportunity to remind the customer that, hey, those $20,000 that you paid us last year are still adding value to your life. That was not a bad purchase because we saved you X amount of dollars this month. Tells them that your solar panel is still active. More importantly, it tells the company, Hearn and Bird, that the solar panel, if it goes out, so they can send somebody out to fix it even before they get that unhappy call from the customer. They wanted to actually have monitoring, so if the panels begin to wear out, they know that they're going to get a call from somebody for a warranty. They can be proactive about it. And they also wanted to control the panel so that they can turn off the output of the panel if somebody was default on their payments. So they did not want to have to go out. They're pretty simple and clean Internet of Things application. Measure the power for using a sensor and have an actuator out in their field that can turn power off as needed. So that was basically the system, and I won't go into the details of this system. By the way, big fan of Python here. The entire system, we actually wrote it in Python. It was using Flask, and we actually had TCP ports. The software over here was actually written in C, but there was a Python emulator for it for testing and QA purposes. Everything over here was Python Flask that was generating the reports and then sending everything out using Amazon's simple email service, again using the Python APIs. So that's a separate discussion on how that system works, and it's pretty interesting in itself. It was all running in Amazon Web Services. What was more interesting was we finally delivered the system like early this year, literally like first week of January post-Christmas. And the company Hearn and Bird looked at it and they were like, okay, this is cool. So they started using it for their own customers. But even more interestingly, they actually showed it to some of their competitors / competition people that they were competing with, but also had some friendship. And they all said, well, we want one of these too. So the bit flipped in the head of Hearn and Bird business guys that we've built something that other people are wanting. Why don't we start selling this monitoring infrastructure as a service to our competitors and turn that into a revenue stream, because we have an actually interesting solution. So they basically came back to us and they already had somebody giving them a check of several $1 million to do this. So they were like, can you guys just put something together really, really fast and turn this into a multi-tenant system where Hearn and Bird is not the only solar panel seller. There are other solar panel manufacturers in Australia that could be using it too. So they wanted this system, but they wanted the system done n times. At the same time, just to make life harder for us, they wanted to be sure that the cost did not go up exponentially because they were not expecting a lot of customers right away. They wanted it to be scalable, they wanted it to be maintainable, and all the good stuff. And they wanted it yesterday. So we started brainstorming between the developers and the operations, and I kind of really liked the approach, the way it evolved. So the first thing was the developer solution. Most of you guys probably thought of it this way. Now you want to make a system that's multi-tenant. Let's just add a tenant ID to the database, and every single transaction is going to carry tenant IDs with it, because there's this new notion of hierarchy in there now that Hearn and Bird is one of the tenants of the system and has their own sub-clients, if you will. And then instead of Hearn and Bird, let's call it in company X now also is going to be in there. So for all the clients that are under Hearn and Bird, we should mark them with the ID of Hearn and Bird, and all the clients under X, we should mark them that they are clients of X, and then the entire time series data that we are saving, the reports that are generating, the logos that are happening, every one of them, instead of being a single entity, turns into an array of entities indexed with the client, the tenant ID. That's just a dev mindset. We all jump at that, and I was a developer for a very long time, so that was the first solution that I came up with as well on, let's just do it this way. The problem with that solution is it was tedious. Remember, we needed it yesterday. This required code changes. This is not an easy code base to validate with all these moving pieces. And it was extremely error prone. We were afraid we were even going to break what we have working already if we go in and sprinkle this concept all over the code base. So then the other solution came about, the operations, what I call the ops solution. Let's just create a new set of servers per tenant. A lot of people do that. So for every Hearn and Bird, we'll have one set of a cluster and another cluster for company X that is just about to give them a few $1 million for buying the software. And the problem with that was, I already mentioned, everything was going to be replicated. These were big data databases that were running these reports. Everything was running at pretty low utilization already, and now we added another set of low utilization servers, and we're about to double the cost. Not going very well with the accounting and the CFO of the company. There was high maintenance. Now you have 2 clusters that you need to maintain, a brand new set of servers, and you have low utilization. It's just paying for a lot of resources that are just sitting there most of the time. So, and the next question was, why not we double the number of servers? But if cost is the issue, let's just go with leaner servers in Amazon. So we'll just buy micro instances instead of small or medium instances, because it's low utilization. Well, the problem with that is, and this goes back to performance analysis a little, that when you go to a smaller server in Amazon, you not only reduce the throughput that can crunch through the machine, you also increase the latency, because there is effectively, there are delays introduced by the virtual machine manager inside the actual system. So the page load times just shot through the roof, because most of the times the resources were just T2 on a micro server, they would just wait. So that's where we emerged with the DevOps solution, because this was really Dev and Ops sitting together, and we were trying to figure this one out. That we are not going to do the first 2 of the solution. Let's just say that every tenant just is going to get its own set of Docker containers. The whole idea of why are we doing multiple servers for different tenants? Because we want isolation. We can provide that isolation very cheaply inside of Amazon with having a single or a few virtual machines, but having a different container, a different isolated environment for each tenant. So multiple Docker containers. There were 3 precisely, in fact, for every tenant that we would create, but all go on the same server. Benefits, extremely fast. We, again, used the Python Docker API. It's actually a hidden gem, in fact, I would say, in the Docker ecosystem, docker.py. So as you get more comfortable with Docker, I would definitely encourage you to look at it. I did not find any documentation on it, so I actually had to open the file, figure out what it was doing inside when we used it the first time. But extremely valuable. We actually got the entire, so all we did was, well, every time a new client is going to onboard, we built a simple admin interface. The super admin, if you will, would go in there and add a new tenant. Underlying the Flask application will just go and use docker.py to create a new set of containers and set up all the plumbing and set up a DNS entry to point to that client. And you practically added a new tenant without increasing the cost. And we did some benchmarking, and it seemed like we could handle up to 30 tenants on a single set of set of servers. And there's not that many solar panel manufacturers in Australia, so we really eliminated the need for just growing the infrastructure exponentially. Cost kind of stayed constant, and we basically did not have to change the application at all, because from the application standpoint, it was still running in isolation. Hearn and Bird was running in its own cluster versus Company X was running in its own cluster. No code changes, got the solution down in 2 weeks. The docker.py made it so that the entire interface for doing this was about 110 lines of Python. That was it, basically. We convert a single tenant, extremely complex application into a multi-tenant application with 200 lines of code. The solution worked, did not go shoot the cost too crazy, and since each individual tenant was still running, we were able to still have fast Amazon servers, big Amazon servers, so the latency was still high. The page loads stay where they were supposed to stay, because you still got the full share of the CPU, if you will. You were on a bigger Amazon server. So the takeaway, one of them was that DevOps is bigger than DevOps alone. The next thing we got, obviously, was that Docker is actually very, very effective at so there were two concepts that got proven here. One was a multi-tenancy, applicable in some scenarios. The other one was just a server consolidation, that you can take multiple applications and throw them on a single Amazon machine and get them to cooperate, work with each other, still maintain low latencies, and be actually using the system effectively. Second case study, website called cars.com, one of our clients, and their automotive listing agent, quite large, worth a few $1 billion. And they were looking for a solution where they had some very specific problems. They had like this big plan that they wanted to achieve with the cloud. So they wanted push button deployments of the infrastructure. That was inclusive of like security, application database servers, had load balancing, had a service-oriented architecture. The infrastructure was relatively complex. It had queues, it had data processing. And what they really wanted to do was basically have a dev environment. There were other business situations there where there was churn, employees, it's a growing team, and there was a new employee being onboarded every few weeks, sometimes every week. There's time to onboard those people, set up their dev environments. The average time to onboard an employee was roughly 2 days before they could start actually testing code on their laptops. What they had was an extremely lengthy Word document, which described like install this software and then install this software and then install this software. We actually did this kind of an interesting diff of the environments on people's laptops, and every single one of them had a different environment, because what you finally got from that Word document was not a function of what was in the Word document, it was a function of which month or which week did you run those instructions. Because when you write apt-get, it could get a completely different minor revision and you wouldn't even notice. So the problem of something runs on my laptop, doesn't work on his laptop, works in QA but doesn't work in production was just all over the place. And relatively complex code base, lots of visitors, millions of visitors are actually hitting this site. So they were looking for a more comprehensive solution that could span across different, and they were aware of the fact that their developers would need local dev environments to be really high productivity. So what they were looking for was having this is actually the wording of the general manager of the project, that they were looking for a holy grail of developer environment management, and Docker was what made it possible as a technology. So why should one focus on developer workflows? Well, developers are expensive. You have to compare the hourly cost of developers versus the monthly cost of a server. They're actually quite comparable. If you have the cloud, if you have a server, a mid-size server in Amazon, you can actually compare the two. And this actually hits one of my pet peeves oftentimes when I'm working with different teams and helping them optimizing their workflows, that it's often the mindset that the cost of a developer is not considered in making technology decisions. And it's actually many a times cheaper to spin up a 50 computer QA cluster just so your developers never have to wait for the result of a test or result for a machine to become available, so that it actually comes out to be a lot cheaper to run an extremely low utilization cluster for doing automated testing than it is to save money by having just 2 servers and your developers are always waiting to get feedback on their code. Because developers are far more expensive than actual servers that are running in Amazon. So that's just one of those mindset changes that need to happen. There is hiring, which is difficult and costly these days. We all know the shortage that we all have at our respective organizations. And you have less productive developers that are moving slow, that are debugging these issues because it doesn't work in QA and they're reproducing these bugs. So you have less productive developers, which increases the time to market for new features. So what does the web developer flow look like at almost any other company as well, not just cars.com? You have the developer, they do some local testing. The code then makes it past the local testing into the QA environment and then makes it past into the production environment. What's interesting is, what's very important to note, there's some loops over here that happen. It's not a straight line, really. You can actually have developer code go to local test and fails and then comes back and the developer has to make some edits there. This is the loop that we are all in as developers most of the times. There's another loop. Your code makes it to QA, and then QA says it fails, comes back to you. And then there is another, God forbid, there's another loop from production back to the developer as well, where something fails. And this one's the least expensive, but most commonly executed. And this one's the most expensive, but hopefully least commonly executed. And the QAs fall somewhere in the middle. Cost for QA is higher than local testing, just because it can require the developer to make a context switch. If something fails in here, if it's caught here, it's a lot cheaper because the developer is already working on a particular issue and they just see the problem, fix it. That portion of code is already in their head. Sometimes coming back from QA, say even if it's a 15-minute lead time before it comes back, the developer may have moved on to doing something else. I come from the world of hardware, as I mentioned earlier, so there are QA processes are sometimes so bad that they could take up to 2 days before you actually get feedback on your code. And sometimes there is not even an opportunity to do local testing. And it's actually immense on how low productivity the environment looks, because you have like, I was one of the lead architects on the Intel Xeon Phi processor. We had a team of 1,200 engineers working with us. And the rate at which the code came along for hardware is extremely slow because this phase doesn't even exist there. Developers run something and they just push it straight to the QA, which is a different team. It's like throwing it over the wall. The QA comes back and throws it back at the developers, and that game continues for a while. How long does it take to get a chip out? 6 to 8 years. For a single product, how long does it cost to build a chip? Something north of $1 billion typically. And all of that actually plays in not having the ability to do these loops quickly. So in web, we do actually have that luxury that we can do these things, and hence highly encouraged. But the key to note here is least expensive but most executed, and often underappreciated, because that's where 95% of your developer time is spent. Make a change, test on your laptop, make a change, test on your laptop. So what you want the developer environment to be is as close to production as possible, because if your dev environment, if you're going through this loop, and this environment looks nothing like the QA or the production environment, you might as well not have it, because it's just going to mislead your developers into thinking they have working code, and the code's going to make it here and then just come back. So you want it to be production-like. You want it to be quick, because this is a very tight loop. Every time a developer is running a test, if it takes 10 minutes instead of 5, it really doubles the amount of time that it takes for the developer to get the job done. And it needs to be repeatable, so if they run it first time and they run it the second time, they get the same result. And if they run it on machine A versus machine B, they get the same result. So important to have it production-like, and how do you make it happen? You want each tier of the application to run the same operating system and software versions as production. And I'm talking about minor revisions here as well. The tiers are isolated from the developer device, so it doesn't matter if this particular developer is running Mac OS Lion or Windows 8. They should really both get the same result. That's the repeatability aspect. And then the tiers are isolated from each other as in production. I actually have a story to share here where Ruby on Rails application, so not Python. But there was a gem that there were 2 applications that were in development were just put in on the same machine. We do that all. We all do that in our dev environment sometimes. We would have 2 applications installed on the same machine without any isolation from each other. And there was a gem that was installed globally by one of the applications and was a dependency on the other application. The other application continued to run fine in dev environments because the dependency was getting satisfied due to the other application that was also on the laptop. Eventually, the bug got discovered later on in QA, and they're like, why has this not been caught for all this time? And turns out it was just a simple fact that every developer was running both applications at the same time. So the more production-like you can make it, the better. And then emulating the distributed nature of the application and actually having different tiers isolated from each other is a very big part of it. So that was my example I gave. Just realized that they never really were running getting the particular gem that they were looking for. Just an example. This was an extract from an email at one of our clients that was sent. So I just copied it verbatim. URL is not loading in IE Safari, but is in Chrome. This is only in AWS QA and not in dev or production. This is basically blame shifting happening. We are wondering if there's something in the infra. So this is just the dev team pushing it back onto the ops team that you are not doing the QA right. The environments are non-identical. We've all seen emails like that. just blame shifting and moving things around because the environments are just not equivalent to each other. More about quick, if you have to wait, it leads to just waiting, waste of time, frustration, and most importantly, distraction. The hardware examples I mentioned, I remember interviewing some engineers on my team just to see where the time was going. And if it took about 8 minutes for the QA feedback to come back, almost all of them would either end up on Facebook or Quick.info, for those of you who know what Quick.info is. So they would either be looking at cricket news, and then it'll take 30 minutes for them to actually come back and start doing real work. So the impact was a lot larger than you would think it is. And it was actually a Fortune 100 company, so check Quick.info or Facebook while it runs. The process has to be repeatable. So if the process is just something like install software on your device, follow these documentations, and ask away if any questions, that you might as well, every time I see this statement, it's like you might as well not have it. It's like having a miscellaneous category at the end of anything that you have categorized, because eventually everything ends up being miscellaneous. So this is just prone to human errors. This is prone to third-party changes. You might have a bash script to run on your device. Here's a vagrant file. It's the most sophisticated of the environments. Still have the same problem. It has outside dependencies. The minor revisions are not specified oftentimes, and would lead to issues with I remember there was one client where they were actually importing a binary file straight into one, moving from one MySQL to another, and a revision in like the third decimal place, a change in the third decimal place actually broke the binary format just a little, and they started running into errors. So things like that happened there with the story. In fact, so that's the MySQL Percona example, and updated it. The vendor basically uploaded it, they did not realize, and the software stopped working. So what we did here was, with putting it all together, the idea was, let's just try to do a homogeneous environment which will go from dev to production and have you follow those three properties. This one's quick, stay production-like, stay faithful. This project was done about 6 months ago, so some of the tools around Docker were not as mature. I would do it slightly differently, and I'll talk about that in a second if I were to do it again today. But you have your developers. What we did was we said the local test environment would consist of Docker, Vagrant, and Chef. Vagrant, because you want to spin up a virtual machine with Linux on it. Even if you are on a Linux laptop, you are required to use Vagrant and spin up a virtual machine, because everyone would have a slightly different flavor of Linux on their laptops. Docker, because inside this Vagrant box, every one of the application tiers were isolated from each other and had an IP address. We were not using localhost : on any of these. There was a real IP address to every other tier of the application, just like you would have in production. And then for each one of the Docker containers, we were using the exact same Chef recipes across the 3 different tiers. So individual servers are identical because Chef is being used the same way. Docker containers are keeping it the distributed nature of the application, and Vagrant is keeping the environment isolated. Vagrant plus VirtualBox really is keeping the environment isolated from the underlying setup. So we had one Docker container for each application tier. Have a Vagrant setup where Vagrant would run a virtual machine with folder sync and port forwarding. This is important because you want to make it it still needs to be, if it's not quick, we talked about that, it's again useless. So you don't want to introduce discipline into developers, you just want to give them the tools that will allow them to do what they do and still have the right amount of discipline. And so no enforcement on you need to use this IDE, or no, you need to have this folder structure on your laptop. Just keep it simple. Just basically specify the folder that you keep your code in, the port that you want to access the application at in the Vagrant file, and it'll just set everything up. The developer still codes in their favorite editor, whatever that is. And there were scripts that would actually take care of the entire setup. And then we had Chef, which was to bootstrap containers in Dev and AWS instances. So how did the system really look pictorially? So you have a developer laptop. Inside the developer laptop, there was a VirtualBox VM. Inside the VM, we had multiple Docker containers for different tiers of the application. They were isolated from each other, and they were actually connected to each other via just TCP/IP, which is the web had the IP address of the app, and the app had the IP address of the DB. And each individual container was brought up using Chef. One of the very key things that was here is this folder sharing that we were using. So remember I mentioned volume mounting in Docker. So we basically, what we had was we used, from your laptop, a folder would be mounted into the virtual machine, and that folder would be mounted also into the Docker container. So any changes, so this folder kind of spans across, it's visible inside the application container, but it exists on your laptop's operating system, which means you can make changes right here with your favorite editor, and the changes would in real time be propagating into the application. So if you're using something like PHP is where it works really neat, where if you change PHP over here, you will immediately see the effect of that on this web interface. And this was just a fixed IP address on the laptop where the developers can actually hit, make a change here, see the effect here, extremely fast churn. So it's fast, it's production-like, very similar in setup to production. And it's basically faithful, quick. And there was a lot of setups. There was a repeatable process. The setup of this was actually a repeatable process which was enabled through a shell script that would just do all this plumbing, and there's several verbs in that. And the results, actually, before I go there, so there's actually, basically several verbs that enabled this shell script to set this environment up. But in fact, what we converged on was something very interesting, that the operations team could actually own whatever is shown inside the white box, because it's the chef and all that stuff. The entire virtual machine is just a virtual machine at this point, a virtual box.box file that you can actually put on a USB stick. And when a new employee comes into the company, plug in that stick and they double click and they get a working dev environment. So that time that took 2 days to set up got shrunk into minutes or hours as the developers, and they had a faithful development environment similar to everyone else, and it just ran. So the entire frustration of getting an employee started went down from 2 days to just a few minutes. And if somebody made a major change over here from the operations team, people could just either do Docker pulls for the most savvy, and for the less savvy, they could just delete their box file and download a new one. Business guys were using it. The front-end developers love it because now they no longer need to know what's happening in the back end. They can still be testing their code. So all that combined, and said very casually, basically, we stopped hearing these complaints. Works on my machine, but not on yours. I've been helping the new hire set up her environment all day, and we've all seen that. IT guys must be doing something differently in staging, because it works on my laptop and doesn't work there, and I can't try it because IT has not updated the dev environment. So, and because IT, if something works on your local laptop with that setup, that means that it's operations who are supposed to take care of. Operations is supporting that environment. If it works in that environment, it ought to be working in QA and production, and if not, there's a clear separation of roles here on who's going to fix what. So who sees the benefit? The operations. There's only one standardized dev environment to support. If it works, it works. Doesn't work, doesn't work. Backend developers, homogeneous environment, much quicker feedback, all set up for you and for all your colleagues the same way. And it's just agile. This was actually something interesting. This was not something we had anticipated right off the bat. When we envisioned the project, we thought that this setup would be built and then developers would use it, and maybe new hires would use it, and then a month or so the developer would actually maybe do an update when the operations team forces them to do. What we discovered was it was actually a very interesting effect on the team, where developers now knew that they could break stuff in their local dev environment. How many of you don't try different versions of software, for example, on your laptop because you're afraid that if you do an update right now, your dev environment's going to break and then you'll have to figure out the downgrade? Python virtual envs, that's exactly what they tried to solve, that you could try different stuff and not have the fear of breaking another environment. So this actually is sort of the virtual env++ in that people started breaking this stuff a lot more fearlessly. And there were some very interesting things that had kind of been sitting on the backlog that came to the front all of a sudden, where a developer just spent a weekend just trying something out and made major changes to the architecture that changed the Ruby version and just made sure it actually does work. Different versions of gems. So this was something that we learned as a lesson from the exercise. From a management standpoint, just less conflict. There was faster time to market, just better churn rate because things were actually working. There were less feedback loops being executed. Happier engineers, that was one of those things that Kevin Reddy, he's the manager, he was the project manager from cars.com. who made me put this bullet in here, that he actually did feel that the morale of his staff was slightly better because they were not doing just regular silly things all day and just trying to find bugs between my laptop and your laptop. And they had an easier time hiring, and employees would be more excited when they actually showed that they had an actually better system. So front-end developers, there's quick visual feedback with populated data, and they could avoid the installations that they were seeing. So why we use Docker in this project? Minimal performance overhead. So think about doing the same thing. It's actually possible to do it without Docker. You could get the exact same boxes, if you will, on a laptop by running one tier, and each tier in its own virtual machine. Doable, but going back to the first comment I made, the lightweightedness of Docker containers, that you would actually then be running, for example, for an environment like this, you would actually be running 6 copies, 6 virtual machines. Most of us don't own laptops that can actually run 6 virtual machines and still stay functional. Actually, I own a MacBook Air. This one tanks at 2, as a matter of fact, doesn't even go up to 6. And so that was one of the major things, was minimal performance overhead, something that's practical and still distributed. Really fast boot and shutdown. I did not talk about some benchmarking numbers that I typically do, so I'll do it right now. Where we did, at Flex7, did some benchmarking work around Docker, some of the very initial work. In fact, if you go to our blog, you'll actually see a lot of results there. So typical time to start a Docker container is about 250 milliseconds. That's like not humanly noticeable. So what that does is you can actually bring up these environments and destroy them at a very rapid rate in almost real time. Smaller file systems, because you can diff containers. If I make a change, I can just push it. Somebody else can test it out very quickly. Much better collaboration abilities. And then you have your container can as such be taken from your laptop and be run in the cloud. We were not doing it in this particular project, and the reason was that this was also done when Docker was just 0.7. We were not comfortable putting it in production yet. But it's since then, and I'll talk about a couple of other case studies where we have put Docker in production. But you could take that same container and put it in Rackspace or Amazon or your laptop or your QA environment, wherever you like. Variation today, if I was to go back and do this again, this is what we did. Remember, chef, Docker, Vagrant. As Docker has matured, there's opportunities to just reduce the number of tools here. Docker has released open source this thing called boot to Docker, where you can use Docker on a Mac far more conveniently than before. Docker files have matured to a point that I could actually use them for just doing bootstrapping rather than Chef. Chef still has some very important advantages, and there's going to be many places where you would need Chef still, but I think from a Docker standpoint, for simpler applications, it works out pretty well. And actually, this slide is slightly outdated here. It wasn't a will release, it actually has been released. 1.0 is there now. So I mentioned this script that made this entire process repeatable and make it all nice and pretty quickly. So there was this one script, and the script inside of it had functions and subcommands, if you will. Lots of verbs here that were actually used. Had a help command to make it easy to see what all these mean. But the 4 that I want to talk about, one was just built from scratch. So you could just say dev environment sh built from scratch, and this will actually pull all the Docker containers, plumb them together using IP addresses, and set up a brand new environment from scratch. This could actually bootstrap from Chef as well, so it would not just pull Docker containers. It could also be set up to just build from Chef from the rock bottom. Unicorn, anyone of you familiar with Unicorn? I guess it's a Chef. It's not Ruby gathering, but Unicorn is one of those servers like that actually, thin layer servers that can sit between Ruby on Rails, in front of Ruby on Rails. So restart Unicorn. Every time the developer would do a code change, they would just run restart Unicorn, and this will just restart the server software. There was run containers, which will just run a particular container and then stop containers, where if you want to turn your dev environment off for whatever reason, if you want your laptop or more horsepower from your laptop back, you could stop them and then run them again if you like. So between these 4 and then a bunch of other subcommands for the more savvy users, basically turn the entire process into a new hire comes in and just runs one command, and you get an environment, and then runs a few commands for the basic stuff that they want to do. They did have more granular control, so run containers built from scratch underneath does a few things like bootstrap containers. It would also set up like etc host files for plumbing and whatnot. So all that actually got combined into a single shell script. So what did we actually end up with? One of the other challenges was from this project that we needed a full production database on a laptop. That one's hard because this is a really large database. It's the national car listing website. So we had the database was tens of gigabytes. Did not want to do that to the developers. So, but at the same time, while we are putting in so much effort into making dev so close to production, this was one of the challenges we had to solve. So the first thing we tried was actually random sampling of data. So we just said every night a job would run that will take the production database and just randomly sample from the tens of gigabytes, would create about a SQL dump which was gzipped about 700 megabytes and put it in an Amazon S3 bucket. That would happen at 2 a.m. every night. The random sampling actually did not work. That was pretty interesting because for this particular application, if you just did random sampling, you would actually get up with, so these are car listings all around the United States. Some zip codes are much more heavier than the others. Like if you're in Manhattan, there's far more cars out there. So random sampling led to things like Austin, Texas had like 2 cars total, and College Station had 0 cars listed, and so on and so forth. And so what that led us to, and there were features of the site that could not be tested properly with that setup, where most of the cities would have 0 cars in them. So what we then did was we went to a more strategically sampled approach where you would go to a zip code and take a small sample of that zip code and then take a slightly bigger proportion given how big the zip code was. So Manhattan still ended up with more cars, but College Station at least ended up with 1 car so that you could actually test different features of the website. And interestingly enough, in that process itself, we discovered a couple of bugs that the website has been visited by millions of people every day, but had not been uncovered when we basically tried those configurations. One of the other things was the production setup used SQS, the Amazon Simple Queuing service. So we actually had to modify it to use RabbitMQ because you cannot use SQS on your laptop. There was the addressing, which was an issue. Like in production, you have the application server talking to the database server through a host name. We needed to emulate something similar. One of the goals of the project, one of the guiding principles was that keep your dev environment as similar to the other 2 environments. So anytime anyone was writing a piece of code that looked like if env is equal to dev, do this, the first thing we do is we want to get rid of that code. So and we got it down to a point where even the actual IP addresses and the host names between the app and the database servers were actually done such that you did not have to change those IP addresses between dev and production. So database was db.auto.com in dev and db.auto.com in production as well. Now, how did we manage that? In dev, we were using etc hosts to just trick it to route traffic to the local database. And in production, we were using Route 53 to route that same traffic to db.auto.com to the database tier in production. So very, very important guiding principle from there on, where there will be places you will have to diverge. There is environment variables sometimes. I'm not saying that this can be driven down to 0, but if you make a conscious effort of reducing the probability of having multiple properties files, and the more lines that exist in that property file, the less confidence you can have that your dev mimics production. Because if something works in dev, it has to work in production. Automation benefits, there was just more innovation. People were breaking stuff so they could innovate faster. There was continuity. So organization had a better knowledge of what was happening. There was faster iteration on the code. And people were actually more willing to experiment in advanced technology. The third one I wanted to talk a little bit about was, these are a little more recent projects. So now we have matured since. So Taulia is a startup primarily based out of San Francisco, but also have a presence in Austin, one of our clients. And they were facing this challenge that the QA jobs were taking too long. So the 2 ways to do it, I've seen people do it is either you stop doing QA jobs and you just reduce down to a subset. Did not want to do that, so because they were measuring code coverage and they realized that every test was adding value. So they decided that the solution would be tests need to run in parallel. But when tests were run in parallel on the same computer, they would conflict with each other because there was some caching in the JVM that was actually causing problems. So the solution we came up with was, so again, same problem. Just keep that theme in mind, lightweight isolation. What they were looking for was a way to isolate these jobs that could be run in parallel without coming in each other's way. And what do you look for when you want lightweight isolation? Well, you can just use Docker. So same solution very applied there. Basically, run different instances of the QA test, but we run it in different Docker containers. We set up Jenkins such that Jenkins would run the QA jobs. Jenkins slaves, rather than being just test slaves, were actually Docker hosts with Docker installed on them. And there was a Docker file that would create a generic image, like I mentioned earlier, where it had all the dependencies of the application, but not the application code itself built into the image. And then the process flow works such that Jenkins would check out the code from Git, just like it typically does in its workspace. Starts a new container on one of the slaves. A container is built using the Docker file. Then the workspace is attached as a volume to the Docker container. So now the container has gotten access to the code that it was looking for. Code is then compiled and tests are run using that master command on the Docker run command. And then test results, since it's a mounted volume, the application just writes test results where it's used to writing, no code changes required. But they actually appear automatically in the Jenkins workspace because it was just a mount of the workspace inside a Docker container. So no changes to the code. We had a very quick solution which works really well, and Jenkins plays very nicely with Docker. And Jenkins, just like it does, copies results back. So if you have a Jenkins-based workflow, and if you don't want to spin up new servers for every single job, which could cost quite a bit in the cloud, very simple methodology from going to, you can save money and be fast with your QA job, so your engineers are not waiting for just QA results. In our case, this was going into hours, and we managed to increase the throughput of the system by not having to make any code changes and many major changes. A quick study, another one, which is just, this was when we took Docker all the way out to production. So I've talked about how we use Docker in an Internet of Things application, and we used it in development environment, we used it in QA environment. Pinshape, where this was when Docker turned 1.0, so we took it all the way just to see what the effect looks like. So the requirements were they wanted to deploy code conveniently, a very small dev team, they're a startup, so just a couple of people basically. They wanted to deploy code conveniently to production from the laptop. The way that we did the setup was use DockerHub for Docker repositories, and we use DockerHub instead of GitHub as the code delivery mechanism. So that's what most of us are used to doing, is version control systems is what determines what gets delivered to production. In this case, we said it's the container that's going to move from stage to stage rather than the code. So just did a DockerHub, push the code, and basically staging environment, production environment were both in AWS, both programmed very similar to you would have for your version control system, where if DockerHub can actually send triggers when a new Docker version is pushed. So we basically use those triggers, which would trigger the servers to actually do a Docker pull, get the latest version of the container, and just start that. Rather than, and instead of code, so basically you would just build containers, push them to DockerHub. The trigger from the DockerHub would actually make it so that the production environment will kill the containers and new containers are started. Very simple setup, but it actually made it enabled the 2-person dev team to be very productive and very effective at just doing operations. Code delivery was not just automated, that's something you can achieve even today with continuous integration and continuous delivery tools, but this was high confidence code delivery because once the code gets delivered, it was working in a very production-like environment already, so the chances of it working are much higher than just sending a bunch of text files over. Other clients and projects that we have impacted with Docker, Salesforce, more a development environment setup, similar to the cars.com I mentioned. And trucking office, relatively similar, but also wanted to go all the way to production. And then Jet Studio, we have a case study on this on our website. I'll just spare you repetitiveness, but I just want to show a few examples of how it actually could be used effectively. I know Austin's not the closest place from here, but we have a very active meetup in Austin called Docker Austin. And actually, we will be participating in a global Docker hackathon, which is happening on the 30th of this month. If anyone of you is interested, you're very welcome to join us. You can join us remotely as well. We do Google Hangout, so you don't have to drive all the way down to Austin to be a part of this. So that's the sort of the theoretical side of the house that I wanted to cover. Basically, just talk through different projects, different ways to use it, and some concepts. I want to stop here and see if are there any questions. All right, that usually means yeah, right. That's good. Yes, we'll make these slides available definitely right after. Any other questions? Okay, so I suggest we take like maybe a 5-minute break, just everyone relaxes a little. I know I've been talking for 2 hours. And then I'll hand it over to Jay, who can just do like a quick demo of some of the commands we talked about and actually walk you through. And we'll share some resources where if you have a laptop on you right now, you can do at least some basic stuff right away. And then for the more advanced stuff, you can go try it at home once you have the ability to download the larger file size.
Why is your laptop stuck? It's frozen?
Really?
Type.
It's not frozen.
I cannot type.
Something on that.
The server is?
Yeah, that particular server is frozen.
What IP did I tell you? Was it in not?
Okay. Just now got an internet connection, which I figured was half of what you were expecting. What's your presentation?
Mine? It's basically a Google Doc.
Oh, okay.
So,
Oops.
and I'll use the terminal. That's
Actually, probably wanted it in kiosk mode or whatever, but hey, look at that, we have an internet.
yeah.
Yeah, go ahead. You're all
Thank you.
set, I think.
Okay, it's an hour if you interpret Highway 90 as a 90-mile-an-hour school limit. Otherwise, it's like an hour and a half. Okay, that's perfect. So yeah, so I'm due yeah, because it felt like coming over here we were on like a weird side road now in real highway. And I guess that's just
So how will you put the bit.ly?
Sorry? Yeah, I already put the bit.ly over here. I'll just say just go to this link.
What is it, that link?
It's basically it routes to my Gmail, other Gmail account, not this one. Not the
That's
first
fine, but are you gonna go through the online tutorial?
one. No.
Like
We
there?
don't have time, right? It's like close to 3.
Can we do that? I think it's still worth it.
It's pretty simple, so I thought I might not.
Okay, that's fine. Yeah, sure, cool. So what's your Bitly again?
It's this one
I would
BAT.
put it in like a larger font or something on a doc. There's no way.
Let's use this. What else would I need? I would need the IP address of my machine. Is the presentation up? I mean, can this see us?
Yep. So you roughly counted and there were 45 people?
Around 42, yes. 45.
So you're gonna put the IPs up and everyone just writes down one?
Yeah, it's on the link, so
Okay,
I'll
so
just
take about
assign
5
numbers.
to 10 minutes to just set that thing up.
Yeah.
Need to get this damn thing up. 2 minutes to get started.
You can actually, you can take your laptop, I guess. That's fine.
No, the font size on the link is fine. The font size on the IPs.
They actually have access to this Excel sheet. So.
Okay, in that case, let's take it down. Is it on the Bitly link or?
Yeah.
Okay, let's open the bit.ly link and yeah. And we'll ask them to color it. If they choose a machine, just color it.
Okay.
Okay, do they have edit permissions or just read permissions?
I think it is just edit permission.
So you need to give them everyone write permission? Just on the IP list, just right click. Remove this.
Details and activities.
No.
No, I need to do it from my account, right?
Yeah. Start this thing again.
I cannot do anything, right? Other than this. Oh, can view, can edit. I guess this should work.
I've seen this one before.
I still cannot. Now I can. Now I can.
Okay. Then we'll just do it and
Yeah, shall we get started? It's 3, 2.
all right. Welcome back.
Wait.
Yeah, sure.
Ready?
So I guess Jay did actually deliver that you can install Docker on and start working with us if you want with the hands-on. So this is the bit.ly link. It's public Google Drive folder that you can go to, the bit.ly.1v capital A T capital M C capital U. If you go to this folder, inside of it there is a Google spreadsheet called the IP list, which has a list of all the servers that are currently up. So what I request you to do is go to this link, go to the IP list, and if you choose a particular IP, just mark it blue. We'll just do synchronization with using Google Spreadsheets itself. So if you mark something blue, somebody else does not take that because we want everyone to have their own server. So we have spun up a bunch of servers in the Amazon cloud. Please go ahead and get to their login and mark, like just change the color of that cell to blue so we know that you have taken it and nobody else grabs it. So bit.ly link, go to IP list and then pick yourself an IP address. Which I'm beginning to see some color on there, that's good.
You want the font with that?
So I'll just give like one more minute, then we'll move on to the next step.
Okay, let me.
So does everyone who is interested has an IP address at this point? Oh really? With the bit.ly, you're not seeing anything?
You need to log in using your Gmail account. You need to log in via Gmail.
You are? Are you sure you have the URL correct? Just making sure. There's some capitalization here that can be missed. It's Okay, so still doesn't work for you. I'll come help you out there in 1 second. So once you have your IP address, can you go hit the bit.ly link? And if you actually go to the bit.ly link, you can just go back to the bit.ly link from where you chose the IP list. There are some other files there. One of them is actually the PEM file. Which one is?
So it depends on which one you selected. So if it is if it says Texas Flux7 Docker, so you will have to download that particular PEM file. Because I mean, Amazon was complaining about the number of servers that I can spin up in a particular region. That is why I had to go to different regions and spin up new servers and with different keys.
So if you can go back to the IP list here. So if you chose, so most people, as I can see, chose servers in the most left column. So you would be downloading the Python Flux7 Docker. That's the PEM file. Once you have the PEM file downloaded, you can actually, and for those of you who are on Mac and Linux, you'll have to change the permissions on the file to be 600. It's just a SSH security file thing. And then you can actually SSH into the SSH into the machine that you have using that second command. Jay, can you go back to the second command? Can you highlight it or increase the font size, please?
I don't have access.
Oh, you don't have write permission?
I got it.
Yeah, so basically just choose your key file name, whatever you downloaded, and then Ubuntu is the username, and then just the IP address that you picked for yourself. There's also some other files in that folder that we'll need to set up. Yes, one of them is docker install.sh, which is the script to install Docker. We'll keep all these public so you can play with them after you get home as well and use them to create your own virtual machines with Docker on it. But the Docker install will install a Docker client and the host and set up what's needed. So basically what we have here is the shell script to install Docker that would need to run on your server once you're in with SSH. You'll need the key and you'll need the IP list that we've all gone through and chosen IP addresses. So is anyone able to log in at this point with the key? Can you just pick an example and go through?
Sure.
Please.
I am actually logged into one. Zoom out. Is the font okay?
Yeah, the font's fine.
Okay. SSH -i Texas Ubuntu at whatever IP that you have. For example, I have one server with the IP of 54.17.176.103.190. So just type in the IP that you selected and just hit enter. You should be able to get in.
You're able to get the SSH, great. So anyone else? Any trouble you're having, or just?
But question, you still need that if you have your own Linux laptop, or?
You could do it on your, if you have,
you can
do it on your own Linux laptop. That's perfectly fine. Basically, it's just a way for all of us to be sort of on the same page and have a Linux box. I saw a lot of people who did not have Linux. So, anyone having trouble going through this?
Oh,
you will be installing Docker. This is just a plain vanilla Linux, Ubuntu, nothing on top of it. One of the things that we'll be doing is running that Docker install script that actually installs Docker.
Security-wise, should our permission file be a certain mode?
Yeah, it should be 600. That's what tends to work. So if you're getting any permission issues, then it's 600 that you want to make it.
You can also transfer the Docker install.shell script to your remote server using this this command scp, the PEM file path to your shell script, Ubuntu at the IP that you chose, colon, and the home page. I mean the home
directory.
Yeah. And then log in and say sudo bash docker install.
So basically, the first three are sort of the prerequisites that you need to satisfy. All chosen an IP, SSH into your server, make sure you can SSH in, SCP the file over using that command, and then just run sudo bash docker install. And if you can, please somehow nod to me or indicate to me that you actually got it working. You're still having trouble, by the way, with the permission? Okay, good. Yes?
I'm just getting public key denied.
Are you using the Ubuntu as a username? So it could be one of the two things, I guess. It could be the username or the key name.
Which region IP did you use? I mean, did you solve?
Does it work?
Did you solve your issue?
Oh, great, thanks. Are you able to do the SCP and run Docker? So I see some heads nodding, that's good. So maybe wait a couple of more minutes for everyone to be on the same page before we start playing with Docker.
Let me see if I have Docker installed here. Let's.
So did you just run the command?
Yes.
Yeah, so this is what you should see when you run the Docker install command.
Can you go back to that screen?
By the way, for you all at the back, are you able to read the commands easily, or should we increase the font size a little? It's good, thanks. So again, if you've done with the install, then you can actually start the Docker pull next. And I'll just go through the command, which is basically, once you have Docker installed, the first thing we want to do is pull one of the base containers. In this case, we're going to pull a container for Ubuntu 12.10. Just the command is sudo docker pull Ubuntu :1210. It's just basically saying pulling from repository Ubuntu. What an interesting detail here is when you do a Docker pull, after the colon you can specify a tag. This is again very much like a git commit ID, if you will, or a branch ID, where you can specify if you wanted a particular tag, and in this case we pulled the image tag with Ubuntu 12.10. Actually, no particular reason why we chose 12.10, right? So it could be, you could use CentOS, or it could be BusyBox, Ubuntu 14.04, whatever you like. So any successes with Docker install? Anyone having trouble with the Docker install? Yes, sir. Are you getting some error? Or? What's that? The SCP file? Like when you SCP it over, it just doesn't show up on the remote server?
Yeah, right. It's not showing anything.
Okay, let me come down there and help quickly. Okay, Can you show me the SCP command that you were running? That looks good. You'll have to put a colon dot after that. Like no space in between. 220 and then colon dot. You should be fine now. Okay. Yes, sir. So yeah, SCP has this thing where if you do not put a colon dot, it does not realize that it's a remote server, so it will actually locally copy the file. Yeah. So after the IP address, you can just put colon dot. That's what tells SCP that it needs to copy it to a server rather than just making a local copy. Otherwise, it just behaves like CP rather than SCP. Anyone else having trouble? Perfect, yeah. Sorry. Host key verification failed. Are you certain you're using the correct PEM file? Are you able to SSH in?
No, I'm not doing SSH.
So most likely I think it's the key. So yours is 224.168. Can you go back to the IP list spreadsheet? Let's make sure. So which one's yours? 224.168. Pytexes, Flux 7, Docker. Can you go back to the terminals? Can you try one of the other IPs just in case there's something wrong with this one? Just pick like a, yeah, that one. Yes, sudo docker pull. So what the Docker pull is doing is it's like the equivalent of git pull. It's pulling a repository. Ubuntu is the name of the repository, and the 1210 is the tag. And yes, if you are at that step, I would say go ahead and run this command sooner rather than later. It does take a few minutes.
Let's see. Don't you need anything else here? It's not getting it.
It's a colon. I think that's probably, and it's a.
You did your colon for as well?
Yes.
Okay.
There you go. Up to you really, but we just use 1210. Like I said, there is no particular reason. It's just arbitrary. And in fact, that's something that I did not mention earlier in talking about concepts is that the Docker container can be a different Linux distribution than the underlying host. So the host in this case, I believe, is an Ubuntu 14.04, and the guest is just 12.10. So you can actually have a CentOS running inside, a CentOS container running inside an Ubuntu. The only thing that the containers are really leveraging from the host is the kernel, and the distributions all use the same kernel. So you can actually have a Ubuntu running inside Fedora or vice versa. Anyone else having trouble? All set. Jay, I think you should start the demo. I can just help out. You had some trouble.
Okay, so it seems like most of you have the image downloaded onto your machine, right? So the very first instruction that we will actually go through is called is called Docker images. So what this instruction actually does is it lists all the images that are present on your machine, right? So we will say sudo docker images. So it says that I have an Ubuntu image with a tag that I just gave it, and this is the image ID, right? So whenever if I don't have a tag to that particular image, I can always go back and reference it via this image ID, which is unique, right? So Docker images basically lists all the images of the OS Docker files that you have. Now,
So when you pull, like, say, Ubuntu 14.04 tomorrow, then that will actually start showing up in images.
yeah,
And the image ID is basically unique, as Jay pointed out, so you can reference it in subsequent commands. A neat trick that you can actually do with Docker containers is that their commands are actually meant to be very automation friendly. So most of these commands return precisely the exact information that you would need to use in the subsequent command. So you can really run a Docker command and have it go to an environment variable and use it in the very next command. It does not require any parsing or anything. So I guess I'll let Jay proceed. So this is the Docker images. They have access to this Word document as well, right?
No,
They don't? Can you make it accessible?
give me a minute.
Sure.
Docker PS.
How many do we actually, let's just keep going and we'll see. Are these, do you guys need access to this file, or is it fine to type? Is it easy to read and type quickly? Most of these are quite short, so we'll make it accessible in a second. Okay, and now it's we've actually copied the commands file in that IP in that folder, the bit.ly link that we had. Can you put the bit.ly link actually right at the top of this file so we don't have to go back and forth? So if you go to this bit.ly link, now there's a new file in there, which is just a Google document containing.
Or else just refresh the page. That should help, I guess. Yeah. Correct.
Just put it in that document, the command document itself. So
Sorry.
you can just go back to the commands document.
Okay.
Just put the link like right up here. So
sure.
as we are working on the commands, if somebody did close that page accidentally, they can come back to it. Yeah, so that's the bit.ly link. And on that bit.ly link, you can now see the list of commands as one of the documents as well. So this is what the document looks like right now. We have went through the SSH step. We've talked about the Docker install. We talked about doing a Docker pull. Any one of you able to successfully do a Docker pull already? So I see some heads nodding, great. Then you can do Docker images and actually see the images. Then we have a command called Docker PS. PS is really just the Linux PS, which shows like, do you have any Docker containers running right now? Remember, containers are different from images. Images are these static entities. Containers are running processes. So right now we have not started any containers. When Jay will run Docker PS, you would not see anything. It's an empty list. There are no running containers. However, when we will go back and start a container, so
Should I just?
yeah. So we have a command sudo docker run Ubuntu ls. So there's few parts to this. There's sudo, there's the Docker, which is running the client. The run command, remember we talked about commands earlier, so it's a subcommand. Ubuntu is the name of the image that we want to run. And the after you specify the required fields in a Docker run command, the last is always the actual master command. Remember the concept of the master command, the container is going to run for the lifetime of the master command and then go away when that command returns. So here we have just put the master command as ls. You'll have to do the tag, I think.
Tag, yeah.
Yeah, so there's a small typo here, so it needs to be tagged. Yeah, so that actually ran the ls command. We'll fix the document as well. It needs to be tagged with 1210 because that's the Ubuntu we downloaded. what's important about this is that this ls did not run inside the environment that you were in. It did not ls the folder that we were in on the machine. The ls actually ran inside the Docker container. And the other thing to note here is how quickly this actually returned. So what happened there was a new Docker container was built from the image. A command was started, ran, and the Docker container was also killed. And this entire thing happened in practically non-noticeable time. That's how fast it is compared to, say, starting a virtual machine and running just a single command and killing it back. So that's the lightweightedness.
They use the time.
So if you lose time, it's barely noticeable. It's less than 130 milliseconds, including a Docker start, including a Docker stop, and the ls itself. And can you run a PWD instead of ls? Just want to show so the master command is something you can edit to see what happens in the container. So the PWD is showing that it's /. It's basically the root, because inside the container, it has its own root file system. So what we were LSing, when we LS'd inside the container, what we saw were like the typical folders you would see in /root, which is like run and like things like bin folder, user local folders, sys folders. That's what we saw. So inside the Docker, to the PWD command, which is in this case running inside the Docker container, it's really running as root. It's running as /. If you do a who am I, can you do a who am I instead of this? So every time we run this, by the way, it's going to create a brand new Docker container. So you can see that who am I, it's actually a root, running as root. So inside the Docker container, you are root, you're running at /, and you have your own file system, your own process space, your own ports. You can control and run your application however you like without impacting the outside system. So can you do a Docker ps -a? So just like our typical PS has flags, the Docker PS has a flag called -a for all. If you do a Docker PS without -a, you would actually see there is no running containers. The reason there is no running containers is because all the commands that we ran created a container but also stopped it, because all those commands actually returned. There was ls, which was a short-lived command, all of them. So Docker PS is showing nothing, but when we do Docker PS -a, which is supposed to show all the containers created, regardless of if they are currently running or not, you're actually seeing 4 containers there. And each one of these containers actually shows what was the master command that was run inside that container before it was killed. So the containers were started and killed. For every command that we ran, a brand new container was started, ran, and stopped. And how is this history maintained?
How long?
Actually, I'm not 100% sure. I've never seen it run out. Let's put it that way. So, and you can go back and delete containers from this history, by the way. It's not all right, so we got the Docker PS, very useful command to know about for all the running processes. Just follow through. So you looked at PS -a. So let's run the Docker, another command. This is, all the commands we ran so far were very short-lived. This is a longer-lived command. We're just going to run a sleep for 10 seconds, again inside a new Docker container. And please feel free to stop us if we're going too fast, if you're having trouble keeping up. So the only difference is now the master command, and remember, this is everything from this point onward is going to be interpreted as the master command. So you can actually put spaces or whatever is appropriate over here. So it's going to sleep for 10 seconds. This is when the sleep command is running inside the container, and it's going to run for 10 seconds. Now notice that your command did not return for 10 seconds either. We were just sitting there. And the reason is that the life cycle of the container is precisely equal to how long the master command runs. It ran for 10 seconds, so our command did not return for 10 seconds either. The entire container basically stayed there. This was running in the foreground mode. I talked about 3 modes that you could run Docker in. In the foreground mode, as long as the master process is running, our command line interface gets hijacked by Docker, and it basically just does not return until that internal command finishes. Now there's other ways to run Docker in addition to the foreground mode. So you could do -d, which is a daemon mode to run small d. It's still the same command, sleep 10, but this time it actually returned immediately. And now while this command is running, if we ran a Docker PS, we will actually see that this command is actually running. So notice PS, it shows live containers, and this live container is currently running at this point. And this is going to go away. If we probably run PS now, it's not going to be there because 10 seconds have finished and the Docker container is gone now. So now if you want to do it for, like, say, a web application, you want to run Apache or you want to run Django inside of it, Django manage.py would be your master command. And for as long as manage.py will run, the container will continue to exist. When manage.py goes away, the container dies with it. In addition to the daemon mode, there is another mode, which is the interactive mode. This is what you use to actually interact with the container. It's the same command, just the master command is different, and you have -i. You'll need a /bin/bash. Right? It'll work, okay. So the path is there, I realize. So this basically gave us an interactive shell to interact with the container inside of it. And you can actually just type ls. Now we are actually inside the container. You can actually do a cd. And the home folder is currently empty. I think if you go in like cd bin or something, you'll be able to, or cd etc, you'll actually see something. So if you go to cd /bin, these are all the files inside the container. And this is just interactive. Again, the master process here is bash. This container is going to run for as long as you are logged into bash. As soon as we hit exit on bash, we'll just do a control D, for example, here, or exit, type exit. Your container is gone that you were working on. So this is something that you can get bitten by as well, where you start in the interactive mode and start installing stuff, and at the end you accidentally hit exit before you save the container. The changes that you made are gone because your container sort of went away as soon as the bash process exited. Yes.
If you did exit, because we're allowed to see the old containers, or we allowed the exit?
Great question. So the containers actually don't really get deleted because if it's a layered file system, it's actually quite cheap to keep them around. So the container goes away from the running state, but it's still sitting in the old state, and you can actually go back and restart it and recover an image from that. I'll spare you guys the details of that. It's just two commands instead of one, quite simple process. So you can get your changes back if this happens to you, where you accidentally exit a container. So if you do -p, so the bash is the one we just ran, and it's like showing up right here at the top level. And yes. Yes, I believe it's the bin bash that is the problem.
If you write bin bash.
If you type /bin/bash as just us being a little sloppy here, you will actually get the prompt.
No, that's fine. You won't see it, but you are still.
You're actually inside bash. You're just not seeing the prompt. But that's really just us being sloppy. We'll fix the instructions and put the right ones. You got it now, right, with /bin? But you're actually in bash, okay. So yeah, well, you can install stuff at this point, like say we can touch a file in a folder, and then go ahead and take a commit. So in like /cd home, like /home being the folder, we have actually touched a file, and you can actually go to another window and maybe take a commit for this Docker container. You have to SSH in.
Sorry?
You'll have to SSH in, no? This is on the local machine.
Oh,
that's why it's not working.
I actually forgot.
So once you have made the change, or the changes that you want to make to a Docker container, like installing software, maybe. So this is just a Ubuntu at this point, which means that we could just do an apt-get and get whatever packages we want, get them all running and tested. The last thing that you want to do is once you feel that the file system is ready, you could go ahead and run a Docker commit. We'll get that here in a second. The Docker commit, what it'll do is take the current file system state of the container and create an image out of it. So it'll snapshot and create a new image. So if you do a sudo docker ps, you will see one container that's running, which is actually the container that's running in this bigger window out here.
You have to have super user root privileges to run all the Docker commands?
That's the default mode actually. There is a way to run it. If you get to be root for a short period of time, you can actually set it up so that it would work as user, and the instructions. It's one of those things you just have to Google and use and just get it working. It can be set up with an SID trick that you can actually get it to work without being root. All right, so we got this container. When you do sudo docker ps, you get that, and now you can just do a docker commit. Now, over here there are two choices. Can you expand the window horizontally a little more? And just run docker ps again, I guess it's the unfortunate reality. Sudo docker ps. So this is the one container that's running, which is our bash job that's running on the other side, the image name, everything. So now there's two ways to reference this container. One is the container ID, which is unique. And the other is a more pronounceable name that Docker actually gives to each container. And you can specify that name. When we ran the run command, we could have done like a ---- tag is equal to and specified a name. Generally a good practice to do that. The one thing to keep in mind is it's not very automation friendly if you name your containers in an automated script. And the reason is that you can only have one container with one name. It has to be unique. So if you write a relatively simple script which is going to go create a container for you, and then you run the same script again, it's going to give an error saying there is already a container with that name. Even if the container is in the deleted state, it's in the stopped state, it will still give you the error. So when you're doing it by hand, it's better to give it a name. In my experience, it's not better to give it a name when you're doing automation. It's easier to just let Docker choose a random name, so you don't have to struggle with that nonsense of making sure the name is unique every time. My comment about, sorry, you go ahead.
Yeah, that's fine.
No, go ahead, run the commit command. It'll actually become very clear. So Docker commit is the equivalent of git commit. We have the container running over here. Notice that we don't actually have to stop the container to commit its state. We'll just hit the commit and basically specify the command. So this is what, so Docker commit, basically in the background, it has just created another image. If you do sudo docker images, you will now see that there is a new image created here. So that's the new image we just created at the top, new_image, which is the file system image of what we had over here with the readme.md file that we created. Now there's a few things to note here that are important. One of them is that when he ran that docker commit command up there, notice what the return value for that command looks like. It's actually a long, ugly hex string. And that hex string is actually the same as the actual image ID of the new container that was created. So that's what I meant by this, it being very, very scripting friendly, because you can just take literally in bash, just put a $ in front of the command with 2 parentheses and get the ID of the container. So your command in a bash script would look something like image ID is equal to $parenthesis start, and just put the command in there and you'll get the image ID out. So it's extremely automation friendly. You don't have to do any parsing from the std out to figure out what was the ID of that image that you just created. So just a valuable thing to know, and you'll see a lot of code, very compact code written that way. So once we have the image ID created 12 seconds ago, the virtual size of the image is there. And while we have a container running and an image there, we can also do, if you want some more information about a particular image or a container, you can also do a command called docker inspect. It's just to inspect something in detail, and it just prints out a lot of output if you want to do docker inspect on that particular container that we have running. So it's a JSON file, again, done with keeping automation in mind, so you can just pass it through something like JQ. And grab the fields that you're interested in. And it prints out a lot of useful information. This is one thing that what Jay just highlighted. He's right in that this is the most common reason why you would run docker inspect. In my opinion, that's the only reason I run docker inspect, is to get the IP address of the container. So every container actually has that network settings blob, inside of which you have the actual IP address of the container. The way we typically do this is just grep for IP address on docker inspect command, and it'll just print out the IP address of the container. quite useful and valuable to have something like that going. And then similarly, there's lots of other information in here. Includes like what volumes are actually mounted, where are they mounted from, where are they mounted to, when was this container started. So you can get all kinds of information through this JSON box, through this JSON data. Sorry. Yeah. A few things we did this, create some files. So there's a couple of things that, so we basically looked at how to start a container, how to commit it. A couple of other things that are important here also, like we talked about two things, which is each container has its own set of ports. So to the application inside a container, it has access to 65,536 ports. Similarly, it's had its own file system, and you can do some mounting. Thanks, Jay. So, and we can actually do some mounting of volumes from outside. So that's what we're just going to demo next quickly. So you can actually do, how would you actually mount a volume from the Docker host where Docker is installed to the Docker container that's going to run inside the host? Going to create a file on the Docker host where you're running your Docker commands. Just put anything in there, just a text file, just to demonstrate the concept. And then we will take this folder where this file is and mount this entire folder inside a Docker container. This is what I meant by when we were talking about the QA application use case, that your application code better not be baked inside the container, otherwise you'll be baking the container over and the image over and over again. Instead of baking it inside the image, you can just set up the image such that as long as you can mount a folder from the outside with the code containing, your QA jobs would run flawlessly. So how would you actually mount? It's actually a very simple syntax. So you just, on the run, just like we did other things on the run side, we could actually do a -v as another option. And with -v, you can just mount the first thing, the thing to the left of the colon is the address, the actual folder on your Docker host. And to the right is the mount point inside the Docker container. And the rest of the command looks very similar. So just go ahead and hit it. You need a -i, because so in this case, Jay did not put a -i, which means the Docker actually ran in the foreground mode. And in the foreground mode, the bash just goes ahead and quits immediately. Bash only runs when you put a -i, which is the interactive mode. So foreground mode, daemon mode, and interactive mode. If you really want to interact, you need to have a -i. So -i gives us that interactive setup. And Jay actually went ahead and put that folder, mounted that folder. If you look at the -v command up there, it's take /home/ubuntu and mount it at /mount as the mount point inside the container. Now inside the container, he did cd mount, cdmnt, and ls there reveals the file that we actually created. And if you create a file here, you will actually be able to see that file outside the container. So it's just a simple mount, like an NFS mount would work, but from the Docker host to the actual file inside, to the actual container.
Should I exit?
Sure. And do you still have a container running? And sometimes so this was the container that we had started earlier. It's been running for 10 minutes now, as you can see. Now, if you want to stop a container that is running, you can actually just run a docker stop command. And the stop command will actually stop the container. And this will stop the master processes and any other processes that were running inside the container. So it's like the equivalent of stopping or suspending a virtual machine. Now, if you run PS, there will be no containers running there. So that was primarily what we had in mind. Do you guys have any questions or anything else you want us to show? Yes? You mean, yes, you can, so you can't save the contents. So the concept of a mount is that it will always stay on your laptop, say your laptop is your host or your Amazon virtual machine is your host. So the Docker host and then the container runs inside. So if you save a Docker image, it will not save the volumes. The volumes are a part of, volumes are not a part of the Docker image. They are a part of something that you just plugged in for running it. And if you take a Docker image, it will not contain the volumes in them. Correct. Every time you run that image, you will have to mount it again. Now, this is where I mentioned something earlier about DockerFile, that Docker files do allow you to put a volume command in there. And that allows you to do this precisely what you're trying to avoid here, which is that I can build an image such that it always grabs the volume and mounts it. There is a trade-off there, which is that you can actually create your image such that it always mounts stuff automatically, so you don't have to put the -v command on your Docker run command and mount it every time. That's the upside, that you don't have to do that every time, and remember to do that every time. The downside of doing it that way is that now your container is no longer portable, because the container has a hard-coded path on the host that it needs to mount inside, which means that you might have mounted it at, like Jay did, at /home/Ubuntu. And now if you send that container to a friend and they use CentOS and they don't have anything called /home/Ubuntu, the container will not run on their laptop. Yeah, you could actually specify a relative path, yes. So that's one way to get around it. Still generally not a great practice, but you're absolutely right. You could actually, if you can provide the project structure such that the relative path is always going to be there. That's correct, yeah. So, but the only thing then you have to remember is if at any point you change the folder structure of your project, you'll have to go create a new image. Other questions?
It's a higher level question. I don't know.
Sure.
You talked about not leaving the code into, what do you call a set of containers?
What do I call what?
A set of containers. Because right now, most people are looking for a set of them. What is that?
Does not really have a name for a set of containers. You may have an application which has multiple containers. Is that what you're thinking? So yeah, it could have like an entire cluster. There are some really good tools out there that's sort of the advanced tier users of Docker. There is a tool called Maestro, Maestro, which is really all about managing multiple Docker containers at the same time. So you can create a Maestro file which can specify more than one containers, just like a Docker file specifies what you want to do with only a single container.
So your application made up of a set of containers, and you're not making the code portion of it. How, if you had a team that was keeping up to date with all of the containers, what was your process
I believe I do actually. So is your question that you have multiple application containers and you may have, you're not baking code into like say 2 of them because they need code but you're not going to bake it inside? Correct. So how would you manage that? So the case would be both of those containers when they will start, you will have to mount a volume from the outside. And so when you mount a volume, it's just, and you can mount multiple volumes to the same container, or you can mount the same volume to multiple containers, by the way. So this is also a cheat trick to make multiple containers talk to each other. If you really wanted to have a shared file space between multiple containers, you can create a folder and just mount it to both containers at the same time. And now the containers can actually communicate through that shared file system. So one way I would do it is, for example, if your code is structured, there's 2 ways you typically have it. If there's 2 tiers of your application that have custom code in them, you would either have 2 separate repositories of code, or you'll have 1 repository of code with a code structure with like part A and part B inside of it. Let's use the latter as the example. So you have 1 repository with part A and part B. One may be my Django code and the other one is my Node.js code for handling sockets, for example, very typical situation. So what you can do is the 2 containers that you're going to create for Node.js and Django, one would actually mount just the portion that has the Django code in it, and the other one can mount just a portion that has the /Node.js code in it. Because these are just paths, you can specify it to be whatever subfolder you want it to be. Answer your question?
Yes.
Great.
Let's do ports.
You want to do the port form? Sorry. Please go ahead.
I have one more question, sorry.
Yeah.
The images Is there any penalty for keeping, a large set of images?
Yes, your disk space does begin to fill up. They don't, they're still layers, and that's one of those things that you do run into is disk space does fill up. If you keep on creating containers and images and the containers continue to sit in that state where they're just sitting there and your images continue to just accumulate, eventually you run out of disk space.
What is the penalty of killing an image? Can I kill an image in the middle? Does that mean every other image?
That's actually a great question. So by what I mean by killing an image, there is actually the two commands we did not demonstrate. It's a bit of a next layer of the onion, but you have this command called rm, just like the Linux rm. So you can remove a container, and there's an rmi command, which is remove image. And when you run an rmi command, and your question is very well taken, that these are layered images. If I try to match and try to delete an image in the middle of my layered stack, is that going to work? And Docker is actually going to throw an error. If you have like say 30 images and each building on top of each other, Docker is going to complain if you try to delete something that is in the middle of that stack. There is ways that and again, not something I want you to try right away, but there are ways to do that. There's ways you can collapse layers in Docker, and then you can achieve what you're trying to achieve and save disk space as well, because the layered file system does have a disk space overhead. Because it's like Git, right? Git saves every single version of the code that happens over time. And we've all had that problem where once you put a binary file in there, it just doesn't ever seem to go away from Git. It's kind of the same issue over here. If you put one big file in there, even if you remove it from the next layer, it's just going to stay with the history. So you sometimes have to collapse layers just to get rid of stuff.
You may have mentioned this. Are they diffs of each other, or they're actual whole?
They're just diffs. So they're only storing the diffs. So you have the underlying Ubuntu 12.10 file system maybe, and then there is like the layer 1 and then layer 2 and then layer 2, which is just saving the files. And there is a possibility that a file exists in layer 3 and not there in layer 4. And that file in layer 3 may be a 5 gigabyte file that you accidentally created and committed and later thought you never needed it, so deleted it in the next layer. But now that implies that your repository is always going to download 5 gigabytes. There's no way around it unless you collapse. Exact same problem as Git. So the semantics of actual commits and pushes is very, very similar to Git. The same problems happen here as well. Just like in Git, there are times you have to do a -- force to get rid of a commit because it's just gotten too big accidentally. Same thing happens over here. Sometimes you have to remove stuff out of your history. And I think this one last thing that we do want to demo is show you actually how would you do port forwarding for a Docker container. So a Docker container has its own set of ports. It has its own IP address, as you saw, and it has its own set of ports. So let's say you are running Apache inside a Docker container, which is like at 172.10.1.1, for example. That's the IP address of your container, and it's going to run at port 80 of that IP address. Now, if we want to forward that to the host, you can actually do that by using a -p command. And what this -p does is the thing to the left is the port of your host, the Docker host, and the thing to the right is the port on the Docker container itself. And what this will do is this will start a brand new container using Docker run with that volume in there, and will run bash and whatnot. What's important to note is that it will actually take port 80 of this container and make it the port 8000 of the host container. So this is important when you're hosting a website inside a Docker container. You have to have a -p to make that port be ported all the way out to the front. So our website, for example, flux7.com, our company website, runs inside a Docker container. It's got tremendous advantages. We have been doing it for about 6 months now. It really helps us with backups and things like that, because Docker, if you want to backup data, all it does is Docker commit and Docker push, and you have a backup of the entire website, if you will, with code and data and assets and whatnot. It's a WordPress site, so we don't need to go very fancy, and we don't get 1 million users either. I wish we did, but we don't. So what's important here is that we do have to use a -p command. In our case, we run only one container on that server, because like I said, Docker is primarily used in our case just for being able to do very easy backups and restores. So we actually do like a -p 80:80, which means take the port 80 of the container and make it the port 80 of the host. Now, anytime you guys go to flux7.com, it hits our server at port 80, and that's mapped into the port 80 of the actual Docker container that's servicing traffic at port 80. You can actually have Docker within the actual host. By the way, all the ports are open for a Docker container. So let's say you have a MySQL installed in one Docker container, and you have a PHP installed in another Docker container. For the PHP to talk to MySQL, all it needs to know is the IP address of MySQL and just port 3306 for MySQL, and it'll just work. So within the host, it's a completely open space. If you want to expose something beyond the host, you have to use -p. Any other questions? All right, I guess it's perfect timing. We are just out of time. So thank you, everyone. Thanks a lot for coming, and I hope you actually found it informative and useful.